Today's lesson, section 9.1b, vectors in two dimensions. So we've already kind of talked about vector form, or component form for vectors. So let us say that vector v be a vector with magnitude and a direction of theta. So then the magnitude is the bars of the vector. And then let vector v represent a comma b, or the point a comma b. And then also we can write that in ij form, which is ai plus bj. And so now we want to represent our a's and our b's differently. So we could actually find our a value by taking the angle of theta times the magnitude of your vector, and then the b could be found by taking the sine of the angle theta times the magnitude of your vector. Thus, we can express vector v like this. So this part represents a, this part represents b. Okay, so there's a different way of finding those two numbers. Now, if you think about what that's saying to you, you have your vector here, vector v, and it is a point of a, b. Now, if you think about your triangle that creates, so let's say our initial point is at 0, 0. So we're creating a right triangle. So this is your component A and this is component B. Now, another way of getting that would be if I use, now if you just use cosine, remember that gives you a value from the unit circle. So if this is theta, cosine of theta would equal your opposite, or sorry, your adjacent over your hypotenuse. But v is not really a value, you need to have the length, so that's where the magnitude comes in. And so then if I multiply both sides by that magnitude, you would get the magnitude of v times cosine. And I could do the same thing for b. You just use sine theta equals b over the magnitude of v. So then that's how those two values are kind of related to one another. And so we're not completely gone from using our trig functions. Now if I have an example 7, vector v has a length of 4 and a direction of pi over 6. I want to find the horizontal and the vertical components and then write those terms in I and j form. Okay? So to do that, I need to plug those in. So for A, remember it's vector v times cosine of theta. So my vector, or my magnitude of my vector, is 4, which is given to me, and the direction is the angle measurement, so cosine of pi over 6. So remember, cosine of pi over 6 is square root of 3 over 2. So you get 2 square root of 3. And if I find b, then for sine of pi over 6. Now, pi over 6 for sine is 1/2. So 4 times 1/2 equals 2. So now if I wanted to write this in ij form, then that would be 2 square root of 3i. Remember, the I is not underneath the radical, plus 2j. And that would be my vector. Example 8 wants us to find the direction of vector u when it's negative square root of 3i and j, plus j. Okay, so to find the direction means that I need to set up an equation here. So a is supposed to equal the vector v cosine of theta, right? Okay, so we know what a is because it's given to us right here. So I can say negative square root of 3 equals the vector of cosine theta. Okay, you can also do the same thing for B. You know that one. So if I plug in 1 for B, because that's what's right there, now for these ones, we don't really know what our vector, our magnitude is, right? But we can actually solve both of these for your magnitude because they're right there, okay? They're both in the same formula, so we can set them both equal to each other if we solve for them. Okay, so now you have two things that equal each other because of the magnitude of V. Okay, so here I could cross multiply. So I get negative square root of 3 over or times sine equals cosine, because it's 1 times cosine. Now here another neat thing with this is, let's say we divided sine over to the other side. Okay, so then cosine and sine actually make cotangent, but I don't really know what cotangent is for my ratios, so we can flip it because we have the reciprocal identities at our disposal. So then that flips this one, so it makes it 1 over negative square root of 3. So where does tangent equal negative 1 over square root of 3? Well, that would be in the fourth and in the second quadrant somewhere. Now I'm not sure if it's going to be a thirds or 6. So let's pick one. So like for 11 pi over 6, now also actually before we do that, if you think about our vector before, okay, now this could give us a hint in which quadrant we're in. So it says that the a value is negative square root of 3 and the b value is 1. So remember, a goes with your x. So if it's negative, it's going this way. And if b is positive, it's your y, it's going this way. So it must be the second quadrant, so I don't have to look over here. I want to pick one of these two. So either 2 pi over 3 or 5 pi over 6. So if I pick one, so let's say I picked the point for 5 pi over 6, and that gives you negative square root of 3 over 2, comma 1/2, and then use your tangent values, so 1/2 divided by negative square root of 3 over 2, see if it works. So multiply by the reciprocal, 2's cancel out, we're left with negative 1 over square root of 3. So here, that matches, so our theta, or our direction, would be 5 pi over 6. Okay? And that would be our answer. Now, another thing here is once we get to word problems with our vectors, two little hints that they want you to remember is true velocity is given by this little formula. Okay, so you're taking two vectors and they're adding it together to get you true velocity. Okay, so usually what that means is that one vector of your object moving and then another vector of something acting on your object together makes your true velocity. So kind of like with your wind, or we'll talk about boats being in the water, so the speed of the water flowing down the river. Okay, and then true speed is just actually the magnitude, so we need to use our magnitude formula. So like for example 9, an airplane heads due east at 200 miles per hour, it experiences a 30 mile per hour crosswind flowing in the direction of south 40 degrees west. Okay, so I want to first figure out the velocity of the airplane and the velocity of the wind in component form, so in those bracket things, okay? And then find the true velocity of the airplane's vector, so that means I need to add my wind and my airplane's velocities to each other to get the true velocity. And then true speed would be the magnitude, okay? So if I have an airplane going due east at 200 miles per hour, okay, the 200 is telling you distance, okay? That's kind of what the true speed is. So here, if I'm looking at a vector value, and I'm always kind of starting at 0, 0 with these because they don't really tell you where they're starting. So if I'm going due east 200 miles per hour, I'm not changing my y value up and down, but I am moving 200 to the right. So for my airplane, that would be like saying 200, comma 0 in component form. And then for my wind, it says that it's moving south 40 degrees west at 30 miles per hour. Okay, so it gives you an angle measurement, and it gives you your length of the value. So let's look at that picture just by itself. Okay, so if I make a triangle, it's going to be in the third quadrant. It's 30 miles per hour, so that's like the true velocity of the wind. So that's like your magnitude. If it tells you it's 40 degrees this way, okay, now that's helpful in the sense that it helps me find the angles, but since I'm in the third quadrant, we don't make a triangle with the y-axis in our point, we make it with the x-axis. So I really care about what that angle is. So since it's 90 degrees altogether, since I know 40 of it's over here, then that means over here it's got to be 50 degrees. Okay, so now I have my angle and I have my my magnitude. Okay, so now also I need to use the entire value. So if that's 50 and this is 180, together it's 230. Now the reason why you want to use 230 and not 50 is because now actually you could use 50, but you have to remember that you're in the third. So if you use 230 when you plug it into your trig equations, it'll take care of your negative and positive signs. If you don't, if you use 50, it won't really recognize it, but you just need to remember that your x and your y are both negative in that quadrant. So then your component needs to be negative for both. Okay. So if I plug in my magnitude, so 30 times cosine of, and I'm going to use 230. Okay, plug that into my calculator. Make sure, because last unit we were basically all in radians, so make sure your calculator can be changed to degrees. And cosine of 230. That gives me negative 19.28. So if you use 50, it would just give you 19.28. So you need to make it negative since you're in the third quadrant. And then 30 sine of 230. That gives me negative 22.98. Okay. So now, using those velocities, okay, so now since I want to find the true velocity, I just need to add the two together. So you take 200 comma 0 plus your negative 19.28 comma negative 22.98. And so then that gives me 180.72, okay, comma, and then the other one will be just negative 22.98. Okay, so then there's my letter B. Letter C, you want to find the magnitude. So the magnitude of this new vector. So I take 180.72 squared plus negative 22.98 squared. So there it gets me 32,659.72, and then plus gives me a 52.08, and if I add them all together I get, so when I add them together I get 33,187.80, and then when I square root that I get 182.18, and so then that would be my true speed, which you put as miles per hour. Okay, have fun.